fluid as it's pumped through cylinders. From crane claws to snow plows to a lot of manufacturing equipment, hydraulic cylinders are truly a driving force in the world. This is fluid power in action. Pressurized fluid pumped into cylinders does all the heavy work, making this forklift actually lift. Production begins with the cylinder barrel. A bandsaw cuts steel tubing to the correct length. Then, computerized tools carve a solid cylinder to transform it into the piston rod. It's this rod that will be moved by hydraulic pressure to transfer force to a machine like the forklift. The tools cut threads in one end and also carve various diameters. This will have a cushioning effect as the machine the cylinder powers cycles down. The other end of the rod will be attached to the piston, which is now taking shape, as a special tool bores through the center to create a threaded hole. Using a special gauge, a worker measures the hole's dimensions to confirm the piston rod will fit into it exactly. Another computerized cutter then carves grooves on the outside wall of the piston. With the piston now complete, they install a web of sealer rings on both it and the cylinder head, which has been machined in a similar fashion. These sealers will prevent leaking of the pressurized fluids as the piston rod moves through the center holes of these parts. This blue sealer will also act as a wiper, removing dirt from the piston rod and keeping contaminants out of the cylinder. This O-ring, installed on the outside of the cylinder head, will stop fluid leakage between it and the cylinder barrel. With the sealers installed, a worker now lubricates the mouth of the cylinder head. This allows for a smooth installation of the part to one end of the piston rod. He then slides the piston onto the other end of the rod and secures it with a nut. He tightens the nut to the rod using an impact gun. Production now returns to the cylinder barrel as a robot welds a cap onto it. The open fitting adjacent to it was installed earlier to attach the hose that delivers the fluids. The worker now clamps the cylinder barrel in a device to stabilize it. He lubricates the threaded open end so he can easily slide a metal sleeve into it. This sleeve prevents snags, so those critical sealer rings remain intact as he now inserts the piston rod assembly into the barrel. Once the piston is safely in the barrel, he removes the sleeve. He then shoves the rod further into the barrel and screws the cylinder head to the threaded lip. Using a spanner wrench, he tightens the assembly to the required torque. He dabs adhesive onto a screw and inserts the screw in the cylinder head. The adhesive dries and expands to lock the screw tightly in place. They now etch the client name, part number, and other information onto the assembled cylinder using a computerized engraving tool. This cylinder is now ready for fluid, hydraulic-grade oil specially formulated to operate under pressure. The technician attaches hoses to the cylinder to fill it with pressurized oil. As the pressure builds at one end, the piston rod extends. He then supplies fluid to the other end and the rod retracts. He runs a finger around the fittings and sealers to check for leaks. He gives this hydraulic cylinder the all clear. After a good wash, a worker spray paints the hydraulic cylinders to protect the metal against rust. Now complete, these hydraulic cylinders are ready to leave the factory. They'll soon be under a lot of pressure to keep machines and mechanisms operating, but it's the kind of pressure they've been made for.